Welcome to day 3 of Chemistry 1. This is for Friday, March 20th. All right, we did leave one unit out yesterday, and that was the mole. We will spend more time talking about the mole later, but regardless, kind of like we use a dozen to describe a number of eggs or a number of donuts, a mole is used to describe a number of particles, oftentimes called Avogadro's number. More about that in a later chapter. Now, a derived unit is a combination of two or more base units. You might be familiar with the unit for speed. Speed is a function of distance and time. In America, we use the mile for distance and we use the hour for time, so miles per hour. If you live in the metric world, distance might be measured in kilometers, but regardless, unit on top would be distance, bottom would be time. Really, any appropriate units would work there. Now, liter may look like a base unit, but a liter is really equal to 10 centimeters by 10 centimeters by 10 centimeters. So if we had a cube that was 10 centimeters on all sides, it would be 10 times 10 times 10, or 1,000, and our unit would be the centimeter times a centimeter times a centimeter, or a centimeter cubed. So 1,000 cubic centimeters is exactly equal to 1 liter. And on a footnote, 1 milliliter is exactly equal to 1 centimeter. So a liter is also equal to 1,000 milliliters. Okay, so looks like a base unit in that a liter is kind of a standalone unit, but realize that a liter is a function of length and width and height. Okay. All right, the next one we'll spend a little bit more time on is the density. Oh, real quick, units. The liter, we can use the gallon, the cup. The tools that we would use would be the beaker, the graduate cylinder, a flask, and things like that. When you read a volume of a liquid, you want to read it from the center of the meniscus. So if this line represents 6.6 and this line represents 6.8, I might estimate the water level somewhere to be between 6.6 and 6.8. So maybe I'll call it 6.7 milliliters. So always read from the center of the meniscus. All right, let's talk about density. Density is basically mass per volume. So mass goes on top and volume goes on bottom. Um, if you want to measure the mass in the metric system, maybe you want to use a kilogram. Volume could be in liters, so a kilogram per liter would be an appropriate unit. Maybe you're using smaller objects, so maybe you're measuring their mass in gram, and maybe you're measuring their volume in centimeters cubed. Regardless, mass goes on top, volume goes on bottom. Any appropriate unit for mass or volume would suffice for density. All right, let's do some calculations. Oh, by the way, density of water is at 4 degrees Celsius, 1 gram per milliliter. So if something is more dense than water, it will sink like a rock. If something is less dense than water, like a board, a piece of wood, it would float. All right, let's do some calculations. So let's say I have a room, and let's say that it is 5 meters long, it is 7 meters wide, and let's say the ceiling is 3 meters high. I could do the length times the width times the height, and I'm pretty sure that number would be 105. Now, the unit would be the meter times the meter times the meter, or a meter cubed. So if I want to calculate the volume of a room, it would be the length of the room times the width times the height, and that would be for a rectangular solid. Sorry about that. All right, let's do a cylinder. Let's say you have a mason jar. And let's say that mason jar has a height of 13 centimeters. And let's say that it has a diameter of 10 centimeters. Okay? So if you want to find the volume of that mason jar, you would use the formula pi r squared h. Now, pi is 3.14159. And radius in this case would be half of the diameter. We said the diameter was 10 centimeters, so half of that would be 5 centimeters. And we're going to square the radius. So we know that 5 squared is 25, and the height would be 13 centimeters. So when I put that into my calculator, pi times 5 times 5 times the height, which is 13, I get the number 1,021 and change. Now, keep in mind, you've got a centimeter, but it's squared, so that's a centimeter squared. times another centimeter would give you a unit of centimeters cubed, okay? So 1,021 centimeters cubed. Let's find the volume of an irregular solid. So let's say you have a little green army man, and you can't do length, width, height, so you start off by putting maybe 37 milliliters in a graduate cylinder. And then you put that army man in there, and he takes up some space, and we notice the water level goes up to 43 milliliters. So we know that the change in volume, or the volume of the rectangular solid, would be the final minus the original. Okay, so the VF minus the VI. The final volume being 43 minus the starting volume 37. The volume of my army man would be 6 milliliters. So in a regular solid, you can use the water displacement method. Let's take that a step further and calculate the density of this army man. So if you want to calculate density, you put your finger over density, and you see that the mass is on the top, the volume's on the bottom. And let's say we put that little army man on a scale, and he has a mass of, let's say, 7.1 grams. We already know the volume was 6 milliliters, so 7.1 grams is an appropriate unit for mass. 6 milliliters would be an appropriate unit for volume, and when I do the calculation, I get 1.18 decimals repeating, and the unit would be the gram per milliliter. I hope this lesson was helpful. There are a few other equations. Remember, if you need help, you can email me. Stay healthy. I love you guys. I miss you. I'll see you soon.